Hi! We're back, and today's lesson is on the topic of gradient. So, I briefly discussed gradient in the previous lesson, but today it's got its own lesson. We are all about the gradient today. So, one of the things that I think isn't a bad idea to start off this topic is to have some fun first. And my definition of fun today is you would load up this website, www.desmos.com. I'm actually going to take you over here and show you what it looks like. Right, so we can load desmos.com, and I want you to then type y equals mx plus c on it, enter, and it creates these slider things. And what this allows you to do is you can change the value of m, the gradient, and see what happens. Right? That's pretty cool, isn't it? Eh? And I want you to look at that and observe, well, what is it actually changing? See the y-intercept. I'd hope you'd, logically say, look, that you can see that the y-intercept's actually changing, right? The y-intercept there is 2 at the moment. If I go up, now the y-intercept's, 2.7. You can see that where it's cutting, the y-intercept's changing. M, the topic for today, gradient, is a little trickier. You'll notice that as you change the gradient, that it changes the slope. See how different values of m completely change the slope? Cool, eh? Anyway, you experiment with that and see what you find. But, more importantly, I'm going to be focusing today, yes, on gradient and how we calculate the gradient from graphs. And that's particular focus. I do like to bring gradient back to this concept that gradient is the change in y for the change of 1 in x. But we'll be looking at that more in future lessons, but I will write that down for now. Gradient is the change in y for a change of 1 in x. If you have loaded up Desmos and you're having a look, it might be interesting to observe that. When the gradient's 2, you should see it going up by 2 for each x value that you go across. When the gradient's negative 2, you should see it going down 2 for each x value as you go across. However, now, I did write that up last lesson. I wrote up the general form of a straight line, the general form of a linear equation as y equals mx plus c. You may recall that gradient in turn was represented by the letter m, and I did briefly mention the idea that gradient is rise over run. So in a formula like this that has values of m and c in there, you should be able to tell me what the gradient is from the formula if it's in that form. So m is the value out the front of the x. So what's the gradient of that formula there, y equals negative 2x plus 5? Anyone? That's right, it'll be negative 2, right? M, the gradient, is what's in front of the x. So in this case here, m, the gradient, is negative 2, right? But in the situations that you'll be dealing with in the text and beyond, we need to be able to calculate gradient. So calculating gradient. So some do it as simply m equals rise over run, and they calculate it from there. I don't like that so much. I like to pin this down a little bit better. I use the formula y2 subtract y1 over x2 take x1, which initially looks terrible, but it essentially says that if I have 2 points and I label those 2 points, I label the first point xy, except I'm calling it x1 and y1, meaning it's the x and y coordinate of the first point, and the second one is x2, y2. If you have 2 points, you can calculate the gradient. Now, I could go through the technical explanation of that, and if you do want it, I will provide it in the future video. However, for now, I'm going to show you this in action. So let's say we had a graph. And I'm going to actually do a quick check and come back to you. Hello there. Just to save you time in watching me draw everything up, what I've done is I've created an axis here with 4 separate lines on it, where the challenge is to find the gradient of each one. So line A is the first one we are going to do. So this is all finding gradient. So in the case of A here, if you look at A, we can see we can pick off 2 points here. Now, the idea is this formula of gradient I've given you here, it takes in 2 points, right? As long as you have 2 points, you can calculate the gradient, you can calculate the slope. Now, we've got a point here that is x is 0, y is 1. At that point there, x is 0, y is 1 at that point. At this point here, x is 1, y is 0. And we've got 2 points. All right? So our points are 1, 0, and 0, 1. All I do now is I put the labels on them to put in the formula. So that's x of the first coordinate, that's the x coordinate of the first point, that's the y coordinate of the first point. Over here, that's the x coordinate of the second point, and the y coordinate of the second point. From there, you can simply put it in this formula. So m, our gradient, y2 subtract y1 over x2 take away x1. I'm just going to plug the values straight in. y2 is over here is 1. y1 is 0. x2 is 0. x1 is 1. So I end up with 1 divided by negative 1, because 0 take away 1 is negative 1. The gradient is therefore negative 1. We found the gradient. Now you notice that there's a negative gradient there, right? Generally you'll find that a negative gradient is formed whenever you're going downwards, right? So we're always walking across in this direction, okay? We're always walking across to the right. We're always happy. We're walking in that direction. If we're going down, the gradient's negative. Anywhere down, so anywhere from going down here through there, we're still going downwards, that's a negative gradient, right? But if we're going up as we're walking along, right? If we're going up, anywhere from there, just even the slightest bit up, all the way up to there, that's going to be a positive gradient, right? So positive gradients are going up, negative gradients are going down. I did need to emphasize that at some point. Okay, so back to our story, right? The first line we had there, line A, ended up having a gradient of negative 1. What that means, if you refer back to this logic here, that the gradient is a change in y for a change of 1 in x, for every change of 1 in x we go along here, we're going down 1, right? You notice that? We went across 1, we went down 1. Every time we go across 1, we're going down 1. Right? Because the gradient's negative 1. It means for every change of 1 in x, we're going down 1. From that, you may even be able to pick off the answer for B before we do it. What's it going up by? It's going up, but what's it going up by each time we go across by 1? Can you pick it already? We're going to do it properly though. We're going to do the 2 points. So let's go on to B now. Now B, this point stands out. It's on the y-axis there. When x is 0, y is 3. Now here, I'll allow you, I'm going to give you this point. You can pretend it was given. I've got it straight in the middle of 1 and 2 there. It's meant to be x is negative 1.5 when y is 0. All right? It's meant to be directly between 1 and 2. But there's our 2 points, all right? Once we've got our 2 points, we can do exactly the same logic and find the gradient again. All right? So B I'm gonna run out of room. No. So for B, our points are negative 1.50 and 0, 3. So remember, oh yeah, we've got to put our labels on. Remember, x1, y1, x2, y2. So that's x at the first point, y at the first point. X at the second point, y at the second point. Alright, so then m is y2 subtract y1 over x2 subtract x1. Again, it's a matter of just plugging in the values now. y2 is 3, y1 is 0. x2 is 0, x1 is negative 1.5. Be very careful. I've got a double negative there. See that? x2 subtract, x1's a negative, there's a double negative. If I take away a negative, I end up with adding, right? That means 0 plus 1.5. So I'm going to get 3 divided by 1.5, which is 2. Right? In this case, the gradient's 2. So with line B, every time you go across 1, we're always going that direction. Every time we go across 1, we should be going up by 2 each time. And yes, I deliberately made the question so that it would end up being that way. Isn't that sad? All right. So next, line C. C is an interesting one. C and D are both special cases. I don't know how much detail I'm going to go on here, but C is actually, M is undefined. Sometimes you may see it described as infinity. Because if you take any 2 points here, if you look back on our formula, x is going to be the same value. You're going to get it divided by 0. What happens when you try to divide something by 0? How many zeros are in 2? How many zeros are in 3? It's undefined. So, you know, I'll just show that as an example. Let's say I took 2 points on this line. 1, 2, 3, 4, 5. So, you know, when x is 5, you could have y is 0. You could also pick another point of 5, 2. So if I picked out like that point and that point, it doesn't matter what points I use, the problem's still going to show. If you put that in your gradient formula, you'll end up with 2 take away 0, so y2 take y1 over 5 take away 5. 2 divided by 0, how many zeros are in 2? Undefined, right? That's how we end up with undefined. So and that happens for all vertical lines. For all vertical lines, M is undefined. You can't actually use it, it all falls over. For D there, whenever you've got a horizontal line, it actually has a gradient of 0. Because think about this, each time you're moving over by 1, how much is the y coordinate changing? What's the change in y each time you move over? Nothing, right? The gradient's 0. If you substitute any values into this formula, you will confirm that. You can confirm that if you want, but the gradient of a straight line is always 0. So, for example, if I pick the points, we'll pick that point there and that point there. So that's x is 0, negative 2, and x is 1, negative 2. If you put that into your formula, so y2 take y1, negative 2 take away negative 2 over 1 take away 0. I've done that quickly, guys, but negative 2 plus 2 will give you 0. 0 divided by 1, it's just 0. No matter which 2 points you pick, you'll get a gradient of 0 for a horizontal line. You can just remember it if you want. The gradient of a horizontal line is 0. Alright? So the gradient of a vertical line is undefined. The gradient of a horizontal line is 0. That's the main point of that. You can experiment with values if you want. That's entirely up to you. The last thing I want to do is show that you don't even need to have a graph. I can give you any 2 points and you can work out the gradient. You don't even need to graph it. To do that, I'm going to get rid of these 2 weird examples here, or do I? Have I got enough room to put it on the side here? Alright, I might try and squish in on the side the last example. All right, the last example is essentially you can find m without a graph. You don't need it. So let's pick up 2 points. Should I make this a nasty example? If you're in class here, I know I'd have a number of people going, come on, make it harder, make it horrible. So, you know, let's do something like that. Let's have 2 and -6 and what am I going to make it? -4.5 and maybe +3.6. Something really horrible, all right? That look like fun? The process is still the same though. We have 2 points. To use our formula for calculating gradient, we put the labels on. So I'm going to put the labels on x1, y1, x2, y2. Always write the formula first. You must get in the habit of this. I'd be lecturing you and annoying you, something silly if you were here. Get in the habit of writing the formulas and then putting the values in. y2 over y1 divided by x2 take x1. This is going to be messy. I'm probably going to have to pull out a calculator at some point. Right, y2 is 3.6. y1 is -6, so it's a take away a negative situation. x2 is -4.5. Take away x1 is just 2. So that ends up being plus. If you take away negative, you're adding. So I'll have 9.6 over -6.5. You know, for accuracy, you could probably keep it in that form. You know what? Let's make it really accurate. Yeah, I'm feeling accurate today. So to get rid of the decimals, because we don't normally have decimals in fractions, what's a trick I could use to get rid of, remember what you do to the top of a fraction, you have to do to the bottom of a fraction? I could multiply both the top and the bottom by 10 and get an equivalent fraction. With the negative sign, it also doesn't matter whether it's on the top or bottom. I'll leave you to think about that. But that would give me a fraction form. And then the question would be, could I simplify that? And that's a good question. Where's my calculator? So if I was going to see if I can simplify that, I can put that as a fraction on here, 96 on 65. It doesn't simplify. So I would accept you actually telling me that the gradient is that. You can leave it in the fraction form. In mathematical methods in the future, going into year 10, 11, 12, it is absolutely fine to leave things as fractions because it's more accurate. It's more accurate than doing the division and rounding it to something. So you could leave it as that. That's a perfectly legitimate answer. I will give you a decimal estimate though, because we can. So the gradient is approximately, so we do the approximately equals sign, 1.477. I've taken it to the third decimal place there, rounded it, because there was only like one digit at the front. So I thought we'll go to the third decimal place. So, negative of course, negative. So if I did sketch that, I'm expecting to see a negative gradient that's not going up too steeply, probably something about like that. 1 is 45 degrees, 2 is a lot steeper, so it's somewhere in between there if we sketched it. And yeah, for fun, you could always sketch that. In later mathematical years, you will have access to graphics calculators and you could try and confirm these things using graphics calculators, make sure it makes sense. So if I had 2 points, 2, -6 would be down there somewhere, -4.5, and then 3.6 would be up here somewhere. So yeah, that makes sense, doesn't it? That gradient value makes sense. You see how it's sort of a modest negative gradient when you look at those 2 points? Yeah, that value makes sense to me. I'd accept that. All right, so bringing it back home, guys, today was a special lesson about gradient, our friend gradient. It is represented by letter M in the standard gradient intercept form. M stands for gradient. You calculate gradient by doing rise over run, or more specifically, y2 take y1 over x2 x1. The main idea, you have 2 points. If you have 2 points, you can work out the gradient. So if you're able to get 2 points off a graph, you can calculate the gradient. If you're quoted 2 points, if you're given 2 points, you can find out the gradient. And yep, there's a couple of special cases. The vertical line is always undefined. You can't define a gradient for it. It's infinity, it's a mess, and horizontal lines, the gradient's always 0. If you can take it further, do try and get a bit more comfortable with the idea that gradient is the change in y for a change of 1 in x. That's always heading this way, right? We're always heading up. So gradient is what you're going up or down by for each change of 1 in x. If you can get comfortable with that concept, it's very powerful in your linear mathematics that you're going to be doing now and into the future. As always, if you have any great problems, please do send me a message and we'll do everything we can within these strange environments and conditions we're in now. Thank you.